Your 3-5 lesson goes over determining functions and operations with functions. We're going to start this. This is a little backwards from what you have, so you might have to scroll all the way down to the last page in order to see what we're doing first. But we're going to first look at determining whether or not ordered pairs are functions, stuff that's on coordinate planes are functions, and then finding the domain and range. From there, we're going to move into your operations with functions. So, first section, we're determining whether each relation is a function. If your x value repeats, it is not a function. So these are easy. The only thing you have to do is look at your x values from your ordered pairs. If any of your x values happen more than once, it's not a function. If none of your x values reoccur, then it is a function. For example A, you have the ordered pairs 1, 2, 1, 5, and 3, 7. Your ones here for your x values repeat themselves. So this one is not a function. For example B, you have 4, 5, 3, 5, 2, 6, and 1, 7. Do any of your x values repeat there? No. So this one is a function. For the next part, you're looking at graphs to determine whether or not they are functions. With these, we have something called a vertical line test. That vertical line, you can put that vertical line anywhere on your coordinate plane through what's already drawn on your coordinate plane and see how many times that vertical line intersects. If it only intersects once, then it is a function. If it happens to where it intersects more than once, then it's not a function. For example A, if you put a vertical line through that circle on your coordinate plane, it intersects in 2 places. So this one is not a function. For example B, you can put that vertical line anywhere. You can put it in multiple places, and it will only intersect once with every single time you draw a vertical line through that squiggly line. So this one, because it only intersects once, would be a function. And for example C, if you drew that vertical line, it crosses twice, so this one is not a function. Next, we are going to identify your domain and your range. Think of this like your ordered pair. With your ordered pair, it's x comma y. X comes before y in your alphabet, so your domain comes before your range. D comes before R in the alphabet, so your domain will be your x values, your range will be your y values. So if we look at example 8a, we have the ordered pairs 2, 5, 2, 7, and 4, 3. Your domain are the x values from these ordered pairs. If the value occurs more than once, you do not have to write it more than once, just write it once. These should also be in order from left to right, from smallest to least. So your domain for this is just 2 and 4. Your range are your y values. So that's the 5, the 7, and the 3. Again, these should be in order from least to greatest, from left to right. So we're going to have 3, 5, and 7. For your next part, you're working with these operations with your functions. We're going to do the odds. You're doing the evens for practice. Whatever we don't finish will be added on to what you're doing. So for example 1 for these, you're performing the indicated operation. It tells you what to find. It tells us that g of n is equal to n squared plus 4 plus 2n. H of n is equal to negative 3n plus 2. We're finding g times h of 1. This is the same exact thing as saying find g of 1 times h of 1. If you have a number inside those parentheses, it's telling you to plug that number in for the variable. So you see g of n is equal to n squared plus 4 plus 2n. If it's g of 1, we're going to plug in 1 wherever there's an n. So that's going to give us n squared, which would be 1 squared plus 4 plus 2 times n, which we said is 1. We will multiply this by doing the same exact thing with h. H of 1, you're going to plug the 1 in for n wherever you see an n in h of n. So that's going to give us negative 3 times n, which is 1, plus 2. In the first set of brackets, that 1 squared is 1, plus 4, the 2 times 1 is 2. In the second set of brackets, the negative 3 times 1 is negative 3. Then we have that plus 2. From here, add within each set of parentheses. The 1 plus 4 is 5, plus 2 is 7. The negative 3 plus 2 is negative 1. So 7 times negative 1 is just negative 7. For number 3, you have h of x is equal to 3x plus 3. G of x is equal to negative 4x plus 1. And you're finding h plus g of 10. So this is the same thing as saying find h of 10 plus g of 10. So we're going to plug in 10 for x in h, then we're going to plug in 10 for x in g, and then add the 2. So for h, we have 3 times 10 plus 3. For g, we're going to have negative 4 times 10 plus 1. On the left, the 3 times 10 gives us 30 plus 3. On the right, the negative 4 times 10 is negative 40. Then we have that plus 1. The 30 plus 3 gives us 33. And the negative 40 plus 1 is negative 39. You add the 33 and the negative 39, and you get negative 6 for your answer. For number 5, we have g of x is equal to 2x minus 5, and h of x is equal to 4x plus 5. We're finding g of 3 minus h of 3. So for g of 3, we're going to do 2 times 3 minus 5 minus h of 3. That's going to give us 4 times 3 plus 5. The 2 times 3 is 6 minus 5. The 4 times 3 is 12 plus 5. The 6 minus 5 gives us 1. The 12 plus 5 is 17. And 1 minus 17 is negative 16. For number 7, we have g of t is equal to t squared plus 3, and h of t is equal to 4t minus 3. We're finding g times h of negative 1. So we're going to do g of negative 1 times h of negative 1. So this is going to give us negative 1 squared plus 3 times 4 times negative 1 minus 3. The negative 1 squared is 1 plus 3. The 4 times negative 1 is negative 4 minus 3. So 1 plus 3 is 4. The negative 4 the negative 4 minus 3 is negative 7. If we multiply the negative 7 with the 4, that gives us negative 28. For number 9, you have g of x, which is negative x squared minus 1 minus 2x, and f of x, which is x plus 5. You're finding g minus f of x. So this is the same exact thing as saying find g of x minus f of x. So g of x is the negative x squared minus 1 minus 2x. The f of x is x plus 5. So you're just subtracting these two. When there's a negative in front of that set of parentheses that comes last, what are you going to do with it? distribute it in. So this is going to give us negative x squared minus 1 minus 2x minus x minus 5. From here, you're going to combine your like terms, keep it in standard form. So that negative x squared goes down first. The negative 2x minus x is negative 3x. Then the negative 1 minus 5 is negative 6. For 11, we have g of a is equal to negative 3a minus 3. F of a is equal to a squared plus 5. And we're finding g minus f of a. So this just means we're going to have g of a minus f of a. So g of a is the negative 3a minus 3. The f of a is a squared plus 5. The negative in front of the second set of parentheses gets distributed in. So it's going to give us negative 3a minus 3 minus a squared minus 5. So again, combine your like terms, keep it in standard form. So it's going to be negative a squared minus 3a. The negative 3 minus 5 gives us negative 8. So negative a squared minus 3a minus 8. For your next one, number 13, you have f of x is equal to 2x cubed minus 5x squared. G of x is equal to 2x minus 1. You're doing f times g of x. So again, this is the same exact thing as saying take f of x, multiply it by g of x. So f of x is the 2x cubed minus 5x squared. G of x is the 2x minus 1. So we're just going to FOIL this out. 2x cubed times 2x is 4x to the 4th power. 2x cubed times negative x is negative 2x cubed, negative 1. Then the negative 5x squared times 2x is negative 10x cubed. And negative 5x squared times negative 1 is a positive 5x squared. Your like terms are the negative 2x squared and the negative negative 2x cubed and the negative 10x cubed. So those combine to give you 4x to the 4th power minus 12x cubed plus 5x squared. For number 15, you have g of a is equal to negative 3a squared minus a, and h of a, which is negative 2a minus 4. We're finding g divided by h of a. So we're just going to take g of a and put it over h of a. So this is just going to be negative 3a squared minus a all over negative 2a minus 4. And we're going to leave it in that form. 17 is just like 15, where you're doing h over g of a. So h of a in this case is 3a. G of a is negative a cubed minus 3. We're doing h of a over g of a. So this is just going to give us 3a over negative a cubed minus 3. For 19, you have h of x is equal to x squared minus 2. And g of x is equal to 4x plus 1. You're finding that little tiny circle means the word of h of g of x, which means you're doing h of g of x. When you see something like this, I would rewrite it the way that I just did, because that tells you to take whatever g of x is and plug it in for x and h of x. So g of x, we said, is equal to the 4x plus 1. That means take the 4x plus 1 and plug it in for x and h of x. So you're doing h of 4x plus 1. If we plug that in for x and h of x, that's going to give us 4x plus 1 squared minus 2. Expand the 4x plus 1 squared and FOIL it out. This is going to give us 4x plus 1 times 4x plus 1, and then you have that minus 2. FOIL this out. The 4x times 4x is 16x squared. The 4x times 1 is 4x. The 1 times 4x is 4x. And the 1 times 1 is 1. From here, combine your like terms. The 4x plus 4x gives us 8x. So that's 16x squared plus 8x. Then you have that 1 and that minus 2, which gives us negative 1. So it's just 16x squared plus 8x minus 1. For 21, you have g of x is equal to 2x minus 2, and f of x is equal to x squared plus 3x. We're told to find g of f of negative 2 plus x. So this is saying take g of f of negative 2 plus x. So the first thing we're going to have to do is to plug in that negative 2 plus x for x in f of x and simplify that. So that's going to give us, let's do f of negative 2 plus x first. So that's going to give us negative 2 plus x squared plus 3 times negative 2 plus x. Again, we have to take this negative 2 plus x squared and rewrite it. Expand it. So you have negative 2 plus x times negative 2 plus x plus 3 times negative 2 plus x. FOIL and distribute. The negative 2 times negative 2 is 4. The negative 2 times x is negative 2x. X times negative 2 is negative 2x. X times x is x squared. Distribute the 3. The 3 times negative 2 is negative 6, and the 3 times x is 3x. From here, combine like terms. The x squared drops down. You have the negative 2x, which is negative 4x, and the positive 3x, which gives us just negative x. Then you have the 4 and the negative 6, which gives you negative 2. This is just f of negative 2 plus x. Not g of f of negative 2 plus x. You just found what's going in for x in g of x. So if you are to find g of f of negative 2 plus x, this is the same thing as saying find g of x squared minus x minus 2. This and this are the same exact thing. So there you go. The f of negative 2 plus x is the same exact thing in both of these. So take this and replace it in those parentheses. So from here, plug the x squared minus x minus 2 in for x in g of x. That gives you 2 times x squared minus x minus 2 minus 2. Distribute. The 2 times x squared gives you 2x squared. The 2 times negative x is negative 2x, and the 2 times negative 2 is negative 4. Combine your like terms of the negative 4 and the negative 2 to give you 2x squared minus 2x minus 6. And then that's your answer.